So in the last video, we looked at 4 alternative ways to write the vector line integral. And so here we're going to begin by summarizing those forms. So we have that the vector line integral, defined by the integral over the curve C of the dot product of the vector field with the unit tangent vector with respect to the arc length, may be expressed in one of the following forms, where the vector field has components f, g, h, and C has the parameterization vector r of t, defined by the components x of t, y of t, z of t, such that t is greater than or equal to a, less than or equal to b. And so we have the following forms for that arbitrary parameter. So we have the integral over the curve C of the dot product of the vector field and the tangent vector with respect to t, dt. And the first alternative form was the integral from a to b of f multiplied by the derivative of x with respect to t plus g multiplied by the derivative of y with respect to t plus h multiplied by the derivative of z with respect to t dt. The second alternative form, we converted this to the integral from a to b of f dx plus g times dy plus h times dz. And in that third and final form, we converted this integral to the integral from a to b of the dot product of the vector field with the differential d vector r. And as previously mentioned, these 4 forms all hold true in R2 as well. We simply just need to drop the z component.